started. I'm going to present today on operating system compliance, automation, and validation. That sounds super exciting. I was told it needed to be a technical presentation, so I've only put a few people to sleep previously, so it's hopefully a little better. So a little bit about us. I'm with Point Incorporated. We've been government contractors since 2009. We specialize in all these things on the screen here. And we are the community maintainers of SIMP. SIMP was open sourced about a year ago from the National Security Agency. And I guess speaking of which, I don't represent the National Security Agency, the government, anybody else, it's just me. And Point technically. But we are the community maintainers, and basically what we're trying to do is we're trying to really, make a coherent and usable infrastructure for automating your system from the ground up with compliance in mind. That's the goal. It is an open source project. It is maintained by the government. Please join, it'd be amazing. All right, so compliance automation. How many of you in here actually automate your compliance in some fashion? Red Hat guys don't count. And actually, I should mention, SIMP right now is focused on the enterprise Linux stacks, the Red Hat systems and CentOS systems. There is some look at going into Windows support in the future. And of course, the reason for that is because Red Hat is presently one of 2 US manufacturers of Linux operating systems that are Common Criteria certified and are FIPS compliant. So those 2 things are requirements for federal systems, therefore we stick to those. This is what we want to do, and if you haven't read Hyperbole and a Half, definitely read it, it's amazing. I was trying to make a slide deck without clouds and memes, and I decided, no, I'm going to have clouds and memes, so memes, clouds. All right, so this is my favorite document in the world, maybe. Right now, we're focusing on step 3, which is implementing the security controls. We are going to talk about basically, how do we take these security controls and make them into something reasonable? Somebody's already done this step for us, which is hopefully your ISO or your ISIs or somebody that knows kind of what they're talking about. There are guarantees there. The selection of the security controls generally is a dump by some security overlords into people that don't care, and they take those and they scramble and try to figure out the minimum that they can do to actually make this thing work and try to fly under the radar. We're trying to not do that. We're trying to implement as many as possible in a very flexible manner. So in step 3, we're kind of combining these 2 steps. But we're assuming that somebody has already selected your security controls. If you're using SIMP, we did it for you, and we mapped them for you, and you're welcome, hopefully. Otherwise, throw rocks and things. Otherwise, bug reports, great. So we're down here in the implementation phase. So how do we actually implement security controls on our systems? There are lots of different methods. We chose Puppet. We chose Puppet about, in 2007, when Puppet was a brand new, shiny object. There was an analysis of alternatives. And if you really want to argue about why Puppet is worse than something else, then I'll happily meet you afterwards and we can yell at each other for hours. It's fine. It is the foundation of SIMP. It is compliance friendly. So one of the things about it is it does application over time. It was designed for applying configurations over time consistently and coming to an eventual steady state. It wasn't designed to do one-time applies. It can do one-time applies, but that wasn't the original intent. And the nice thing about this from a security point of view is that you apply as much as is feasible. What this means is that I can go in and I can say, hey, apply this entire configuration stack. Well, if 2 of my applications don't deploy because somebody made a bad RPM or something horrible happened, it still applies my firewall rules, my SE Linux settings, my lockdowns. So I don't have the system that's sitting out there because something way up here failed. It actually locks it down all the way, and you can get back later and actually go through and fix the things that failed. So from a security automation point of view, it still tends to be very good for that environment, especially for environments that are long-lived. If you can blow away your environment randomly, okay, fine, use whatever you want. Apply something once, roll with it. But if you really need a system to be up and steady over time and you want to make sure that your security portions of your system apply well, you're stuck with it. So also the compile phase, so Puppet is a compiler, and the compile phase allows for system state auditing, and that is a little bit of foreshadowing into the more exciting pieces. How many here have used Puppet before? Puppet right here, guys. This makes sense. All right. So a little bit of an overview of how Puppet actually works. This is very relevant to the actually the rest of the talk. So the first thing you do is you have your data side. You have HIRA, which is basically a hierarchy of YAML or JSON files that allow you to specify particular configurations for your systems. You also have something called an external node classifier. If any of you are using Puppet Enterprise or Foreman or Satellite 6, those all act as your external node classifiers and can actually feed configuration data down to your systems on the fly. These two items can work together. If you use them together, it might be very confusing, but it is definitely possible. And of course, you have your Puppet code, which is a domain-specific language that feeds into the compiler. So both of these materials feed into the compiler. The data that's in these subsystems combines the Puppet code to give you a catalog. And now you all know what this symbol actually means. That is a directed acyclic graph. So basically, this thing takes all its code, smashes it into a graph, shoves it down to the clients for application. So catalog goes down to your client, and in general, the pattern is going to be install the application, configure the application, and then start your service. In the SIMP model, we've actually added on some additional items. We added on configure my firewall and configure my PKI. And we also add in things like system logging, auditing, all those good things as a complete infrastructure. Does all this make sense? Any questions? All right, so this is a bit of configuration code. So over here, we have our public code, a very small snippet of it. This is our SSH Server Configuration file. And one of the things I'm showing here is that we are checking to see if your system is FIPS enabled. We do, as an infrastructure, test everything with FIPS on and off. If you ever want to use, what was it? Radius. Forget it, because Radius does not support anything but MD5. It's amazing. So, so here we're saying, okay, if we're Red Hat or CentOS, then we want these algorithms if we're above level 7, and if we're otherwise, let's just take the fallback ciphers. So this lets us say, okay, let's go in, let's make sure we have the correct set of ciphers for our situation, make them as strong as possible, but make them so that they actually work. If your ciphers are too strong, I know this is amazing, but if your ciphers are too strong, FIPS will actually shut down your application because they're not FIPS certified. So if your keys are 4096 bits instead of 2048, well, forget it, your application is going to crash because FIPS says no. That's really exciting, isn't it? Let's not be too strong now. But that is what was validated by NIST, so it's what you must do. So what this does is once it runs through that compiler sequence that I showed you previously, it combines the data from HIRA and will burn ENC and will dump out your cipher string, your MAC string, your key algorithms, do things like permit root login no, and all the other good things that you like. All right, so how do we actually validate that we are compliant? So now we've gone through, we've applied something in SSH, we want to make sure this thing is actually compliant. So how are we going to do this? We have a couple ways of doing it. The way that we chose is following this special publication 800-137. So now we're in the assessment phase, so you have to assess and monitor. Really, to me, those are the same thing. Your assessments should be continuous, they should be regular, they should be feeding into whatever system you have that's going to be analyzing your data, whether that be Splunk or Elk or something you made yourself. But these two work together. Authorization is kind of an interesting one. From a continuous deployment type scenarios from a traditional DevOps workflow, authorization really is your code review stage. So your developers develop, your operators develop, we'll get to that. So everybody's developing, everybody's pushing through, everybody's testing. Well, how do you actually make sure this is good to go? Well, when you're in a tightly regulated environment, there has to be somebody out there, an ISO somebody, that actually hits the button that says, this is actually okay. So in theory, you want your ISOs to be part of your code review process, and you want them to actually authorize the system by basically going to that code review system and saying, yes, this is good to go. If you ever find an ISO that does this or is willing to do this, let me know, I'd love to hire them. All right, so we are focusing on using SCAP. I always say SCAP because I'm from Tennessee, I'll say it the way I want. But it's technically SCAP. And it gives us a method for standardized validation, kind of. They ended up having to add in the ability to run custom code in SCAP because you have to actually check system state. SCAP was great for checking static files and things like that. But then you looked at it and went, wait, I'm checking static files. What about my firewall rules? Well, my firewall rules are live, and our wonderful friend OpenShift might be manually in the middle, which it does, and it's fine. I mean, that's appropriate. But you want to check the live state. You don't want to check the static file state. And also audit B. I saw some wonderful people that were going in and ninja hacking audit rules to make their applications work by just throwing a rule at the top that said ignore everything. So, SCAP isn't going to find that. SCAP is going to say, well, your audit rule file looks great. Well, that's fine. What about the running state? If the running state is garbage, I don't care what my file says. So, okay, but it is standardized. It is a federal requirement for most organizations. Believe it or not, you can do traceability if you really want to. It's horrible. But SCAP is the de facto standard for federal systems. So we're using OpenSCAP. It's built into Red Hat and all the other systems. There are really good bodies of knowledge behind it with the SCAP security guide. And again, the SCAP security guide is open source, so please participate. It's great. It's being run by the NSA, DISA, and Red Hat at this time. All right, so to run an evaluation, you would basically run OSCAP, XCCDF, eval. We'll output it in ARF format because ARF, I don't know. We'll end up with some results, and this is a data stream that you would feed in that is SCAP content, SCAP content that's been collapsed into a single bundle. All right, so once you run this thing on a system, you'll end up with an open SCAP report. Right now, there are a couple different methods for running SCAP. Obviously, you can run it manually. I believe Satellite has a plugin through Foreman to run it, and one of the SCAP maintainers, Martin Pressler, I believe, wrote an SSH-based blast out where you can run SCAP everywhere. And if you're running the Puppet stack, I wrote an mcollective plugin to run SCAP and gather your data from all your systems in a fully distributed manner. But you'll end up with something like this. So basically, it's just checking the different values in your configurations. It's saying pass or fail. That's what it does. And it'll give you a score at the end. So basically, if you have 80% correct, you'll get an 80, etc. And you can see right here, they're looking at OpenSSH should be installed. Again, automate that through Docker, through Puppet, through something. All right. Okay, maybe I'm slightly exaggerating how amazing this is, but I like it. All right, so what about intent? So this is kind of funny. So now we can go into a system, we can look at the system, and we can say, hey, did this system actually do what I meant it to do? Well, probably. I was actually consulting at a business recently, and a guy walked into my cube, and said, hey, it would be really great if with all this we could actually see if we're trying to apply what we mean to apply. So if the variables that we're feeding into the system are actually what we expect. And I looked at him and went, I was really glad that you said that because we already did that. So that's what I'm going to present next. So now we've gone, I can look at my system, but how can I tell that what I'm trying to apply to my system is actually what I'm supposed to be trying to apply to my system? And more importantly, that it meets internal business rules or compliance policies. So again, what did I mean to do instead of what I did? So what you did is great, but is what you did approved by your ISO? Is what you did approved by the standards? Is what you did approved by the local business processes? And so we need something like code level compliance mapping. And in most languages, this is not possible. But since Puppet is a compiled language, we can actually inject into the compiler. Hey. So again, foreshadowing is great. The compile phase allows for system state auditing. We have HIRA, so we're actually feeding our policy mappings in through HIRA to have a nice standard format that is overridable on the fly in code. That goes into the Puppet compiler. The compiler then we wrote a hook to introspect the compilation phase for all of those subcomponents, and it modifies the catalog on the fly to output a resource that will then give you the report state for your system as to whether or not it is compliant. All right, so we have some assumptions. You're using Puppet, and preferably SIMP because that makes sense. You're using Hira or an ENC. That gives you the ability to set your variables in either place. You can't pull all the mappings out of Hira and put them in the ENC. It would be a horrible time since we have like 700 odd mappings, but you can do it. And you can include functions in the code. So that means you can actually go into your code, into your classes and defines, and you can actually drop a function into those for allowing us to modify the state. And the goal is to report on differences between compliant variables and actual settings on your system. And here is a link if you guys want to hop on there and follow along, which, unlike my last presentation, I actually put on the bottom right hand of the wrapped screen. Well, okay, it'll be there. We got that. All right, so in terms of variables, so I picked out a couple of very important variables, which are our ciphers. So we want to make sure that our ciphers are FIPS compliant or not FIPS compliant based on the state of the system. And over here, in a defined type, so here's the server-side configuration, here is the client-side configuration. Our client side also has a ciphers array, which by default is left empty because it should negotiate it appropriately with the server. What we found is that different implementations of SSH don't do that, particularly PuTTY, interestingly. But you'll want to actually make sure the ciphers are set appropriately on both sides because you also don't want your clients connecting to other servers without using FIPS-approved ciphers. Right, does that make sense? All right, so variable overrides. We have Hira. So here we're saying, so if you look back over here, we have SSH Server Conf and the variable is ciphers. So here we're going to say SSH Server Conf permit empty passwords. True. All right, that's a good idea, right? And SSH Server Conf permit root login. True. So now we can have a root login with empty password. This is the most amazing system ever. Or maybe not. So obviously this is bad. Obviously we want to catch this. This should be against both business rules and common sense and everything else. So it's time to do some compliance mapping. So here again, I'm going to have another URL that probably won't show on the screen. But we did a full mapping to the NIST 853. We mapped it into all of our variables. We have over 750 variables mapped. I say 750 plus because it's irritating to put the exact number. We are working on pulling that out into C2S, CS2. We've actually mapped them already. We're just getting the higher profiles done. So there's C2S, CS2, HIPAA, SOX, PCI DSS, and something else. Oh yeah, the energy one. We are working with the SSG group as much as we can to make those mappings reasonable, but that's interesting. So anyway, inside of our, this is a snippet from our Hira file, which is, you start with compliance, the custom namespace. So compliance, NIST 853 revision 4. That way when revision 5 comes out, we can update everything appropriately. SSH, so then it comes down to the class path. So if you look back here, it was SSH Server Conf permit empty passwords. So compliance, specification, SSH Server Conf permit empty passwords. There's our code. The identifier is IA51A. That gives us the exact section in the 853. And then the value should be false. We do this for every variable that is security relevant that we know of. Patch is welcome. And you can make it an array. So you can have as many identifiers in here as you need. You can map it to as many different sections of your policy as appropriate. All right. So how do I actually use this thing? So here I have a very small snippet of the SSH Server Configuration class. So the class is SSH Server Conf. I have a little bit of setup here, and by default, you just have to include the compliance map function. That's it. If you do that, what it'll do is it'll go through all these variables, or parameters, and it will check them against the contents of that Hira file at compile time. Now, we realized quickly that there are some things that aren't really variable-based, they're more action-based. So it's more, if this piece of logic fires off, I need to have basically a different report for that. So what we did was we added the ability to basically throw in your own little internal policy mappings. So here we have compliance map internal policy, section 1.5b, this was crazy, with the condition that something was crazy. So what this gives you is it gives you the ability to have this pop out in your report, and that way it's completely up to the logic inside of your code. Oh, I actually came out. Well, there you go. There's one of them. Right. So reporting. So after the system runs, what you're going to end up with is something that looks like this. This will actually be saved into a file on the client system. We are looking at adding in a server-side only reporting capability because some people don't like having this information on their clients. But the benefit of having this be a file is that if you're using Satellite 6, Foreman, or Puppet Enterprise, the changes to this file, so the changes in your report will actually get fed back into your reporting system. So that means you can actually analyze it, you can analyze it offline without having to have your server feed into some external system in an out-of-band method. So here we actually have version controlled our compliance mapping output. So we have compliance profiles. This can output as many as you select. So if you want to map your system against 4 different profiles at once, that's fine. You will probably get a report because they don't all agree. So 853 Rev 4, it gives you the class name. So the idea here is that you know exactly where in your code this was actually changed. The parameters, permit empty passwords, the identifiers, the compliance value, and the system value. So here you can see that it should be false, it was true, this is bad. It doesn't actually prevent it from happening, but it gives you a way to actually notice that your configuration is not according to policy. One of the benefits of this is that once you feed this report back into your analysis system, think about how many false positives you normally have with whatever scanning tool you're using. Well, if you know you're supposed to be doing this, and you know it's not compliant, you can just eliminate those false positives immediately. So all of a sudden, hundreds of things can get eliminated from your ISO's daily workload, in theory. That's more amazing. But this was actually very interesting to build. It became really, at first I was wondering if you could do it, and then once I started tinkering with it, it became an exercise in, I think you can do it, and now I'm going to make it happen. And if anybody from Puppet has actually read the code, they're probably going to punch me at the next meetup. So what do we actually do with this thing? So the benefits are you get site-specific overrides. You can have the 853, you can have the stick, you can have whatever you like, and you can say, you know what, this is fine for most people, but at our site, we override these 4 or 5 values to be something different, and that's okay. And that way you can prevent that report from being generated for all your systems constantly. As I mentioned, you can eliminate false positives. So basically you can, like I said, well, it is good. But you can go through and actually trim down your compliance reports over time. So you can run a SCAP, you can then take the SCAP output, eliminate all the false positives, and just get down to the things that actually are meaningful. You can report on unauthorized changes, and this is unauthorized changes to your actual infrastructure as code. So, an admin came in, they pushed something through code review themselves, they shouldn't have, it was a big mistake, but it was 2 a.m., they had to get it fixed, oh my goodness, what's going on? And it's happened to everyone. That's when mistakes happen. I mean, that is the biggest insider threat that we have, is people at 2 a.m. that haven't had enough coffee. So security officers can actually control the mappings. So you give them control over that part. It's just mappings. They don't actually do anything. They don't affect the state of the system, but they affect what the security officers are looking for on the system. So you can go through and give them power over all those mappings, at which point they now know the system is not in the state they expect. And then of course you can also do business policy mappings. So if you have internal business processes that dictate the way your JBoss server should be set up, you can do those mappings and have that get output on a regular basis. That way if it's not set up as appropriate, you get notified of that. All right, so in the future, we're actually hoping to move the function call from inside the classes to a global space. The idea being that we can then do a more holistic view of the entire catalog and have the output. We're trying to figure out exactly how to hook that in, but that would also enable usage for Puppet Forge modules without having to modify them, which is very nice. And more mappings. So we have the mappings from the policy to the other policies complete, and now we have to use those mappings to generate additional higher data files from the original and add in the pieces that were missing. All right. Apparently I went ridiculously fast. So we have lots of time for lunch or questions. So I actually have a backup slide that I'm going to show you for anybody that really wants to dig down the weeds.
So they.
Yeah.
I have a question.
Oh, yeah, go for
so
it.
I followed your link.
Sure.
So I noticed. So the link goes to GitHub.
Yes.
To SIMP core.
Yes.
And so are you the primary maintainers of that?
So
you're the latest commit. So
yeah, I am right. We are the primary maintainers of this. It is developed under contract with the NSA right now. It is, if you go to github.com/National Security Agency, we are the first project that landed there, which was creepy and exciting. So, but actually, it was really good, and we forked it off from there because we have over 100 submodules or subrepos at this point. But yeah, starting a SIMP core allows you to build the entire project and use it, develop it. Yeah. Anybody else? I mean, I really want to, like, was this interesting? Is this something you guys think you could use? It seemed to me to be a gap in the really in the infrastructure as code process. And so we have developers developing, we have operations guys hopefully developing, and those two are throwing things out in the field all the time. But there was really no insight besides just a system scan to figure out if what they were trying to do made any sense. Okay, so this is kind of the interesting bits down the weeds, and since I have time, I'm going to go into it, and it doesn't matter if you don't know. So, all right, the interesting bits. So, like I said, the Puppet server is a compiler. It has a compiler object. So what we did was we took our code and hitched a ride on top of the compiler. The compiler is really the only persistent object during the state of a Puppet compilation run, and we didn't want to leak memory. So how do you not leak memory, but when you can't actually hook into anything that cleans things up? So, well, you know what? We'll just hook onto the only thing that matters. And when it gets cleaned up, we'll get cleaned up. So basically, we dropped this instance variable called compliance map function data. So we took all of our compliance mapper data, and as we run through all the functions, we just dumped it into this object. This object then gets popped back out, and if we have this little hitchhiker on the compiler, we take the compliance map out of it, and we assign the hitchhiker to this instance variable. Instance variables get blown away at every run. This is good. We don't leak memory, but of course we have to pick it up every run and figure out how to persist it over time. So we actually work through here and create the validation report. We build a report with a ton of code right here that's nonsense, and basically it's just taking hashes and smashing them into each other. And then we go in and we actually drop a file resource. So you can create resources in Puppet as code. So we drop in a new file resource, and we set the parameter of content to the compliance map object as YAML. We then add that resource to the catalog. So the catalog is getting compiled, drops it in there, and then we need to actually persist this. So we set an instance variable on the compiler, which is compliance map function data with compliance map, which comes back up to the top, and it just cycles forever through all of the different objects in the catalog. Once this finishes, again, the objects are cleaned up, the memory leaks, good times. Yeah. I think that's actually the end. So enjoy an early lunch. Yeah, if you have any questions, want to talk about different things, like why we did things a certain way, I'd be happy to actually show you some of our workflow. I know there was a lot of talk about DevOps and whatnot, but I don't know how many of you actually have a internal working DevOps workflow. It's actually functional. Yeah, most places don't. Thank you for being honest. So yeah, sure.
So this does like operating system validation, I assume, because I saw you listed STIGs and other things. This doesn't set any of the values or compliance settings that are required in a lot of checklists. Is that right?
It does.
Is more of just checking.
No, this is setting. So this was a presentation on the validation of the values. SIMP is actually the product that does the setting. Okay. So the idea, I'll just dive in there. The idea behind SIMP was to automate the security and maintenance of systems in a flexible and useful way. It started out when I was at DISA, and I had this, they dropped the STIGs on me. I was brand new. They were like, hey, noob, here's the STIGs. Oh my God, what is this? So like everybody else, I wrote a Kickstart file. Like, hey, a Kickstart file applies the STIGs. This is wonderful. The problem was every time I did that, the developers would hop on the system and just start like smashing things out of the way. So it's like, oh, no more IP tables, no SE/Linux, we don't like these things. These are in my way. So over time, I kept thinking about it, going, we need something that actually reapplies these things over time and just does it forever and reports on changes that are made. So again, about 2007, Puppet came along. We were looking at different alternatives. There were CF Engine, BCFG2, Puppet, a few other things. Ansible, Chef, Sol, they didn't exist at the time. And so we took a look at Puppet. It was the most user-friendly language we could find. So here was this really useful DSL. The DSL was friendly enough that I could give it to regular like level 1 admins. I could give it to security officers. They could understand it. They didn't have to actually go figure out real code. They didn't have to look at stacks of configuration data. It was pretty understandable. So that was kind of the goal. That was kind of the impetus there. And then we, as everyone does, we started out, okay, we're going to implement the STIGs. Well, we had to bootstrap our environment. How was we going to test this thing? So it quickly turned into I think actually one of the guys at Red Hat Federal referred to it as the Genesis missile. So basically you drop this thing down as an ISO, it builds itself, and then it gives you the ability to build the rest of the environment. So it sets up LDAP and Kickstart and all your PKI certs, and everything's encrypted, and there's a central log server, and all the things you need to actually run an environment. Because we couldn't make any assumptions. We had a box. So from that box, we started building this environment, and then realized that I could actually do what I needed back at DISA. I could actually build a system that would automate other systems, be user-friendly enough for admins to dig into, and be reasonably impossible for the developers to screw up. You turned off my IP tables. Well, Puppet runs in a little bit, turns it back on. And actually there's one part of it that I like a lot. It's called service kill. It's my favorite. So there's a policy or a statement in pretty much every policy I've read that said you shall not run unauthorized services. Period. Like, well, how do I do this? And so what you should do in any good firewall is whitelist. So I'm like, all right, well I have Puppet code. I can figure out what's in the Puppet code. Therefore, if it's in the Puppet code, I don't turn it off. Otherwise, I turn it off. So, and this doesn't kill processes, it just turns off services. But that way, unless you've actually stated in your configuration that you mean to be doing something with the service, it will turn it off and disable it. So if you reboot, no dice. And of course, since Puppet checks in on a regular basis, we can detect that you've turned off Puppet and then go yell at you for doing that. And in theory, actually in practice, we know who's done it because we have auditing set up, we have all the logs getting centralized. You can really point at it and go, you did this, you're evil, you're fired. Never happens. So that's kind of where it came from. And then of course, the 853 was born in that time. People started doing mappings, the SCAP security guide came out, and we started working with those guys and saying, you know what, this is really nice, we'll take the SSG data, we'll look at this, we'll actually target what's actually being done in the open source community and make it something that everyone can use. And then, as I say, last year it got open sourced by the agency, and it was great.
Does it work with, because I know a lot of times it's hard to automate things in like databases or certain applications. How was the extent, how far this thing goes? Is it operating systems at this point? Or
so right now, it concentrates on the operating system. It uses Puppet, so we didn't do anything weird. That was actually one of the mandating rules, is don't do anything weird. So if you know Red Hat and you know Puppet, you should be able to use this. Okay. We didn't go in and do crazy stuff and make it our own language. We didn't make a DSL on top of a DSL, nothing like that. In terms of what you can do with Puppet, it's code. You can do whatever you want. We have automated databases. Actually, there's a really good MySQL module and Postgres module from Puppet Labs. Sorry, Puppet Code, wherever they are now. It will go in. So it is Ruby code. So you can go into databases, you can modify them. We actually rewrote the format installer because it would stomp all over your Puppet installation. So we rewrote that to work inside of SIMP, and we do go into the databases and actually go and set the administrative users and remote users and whatnot. So it's definitely possible. Any other questions? Let's say I'll be around afterwards, around all day. So thank you.